Hey, I got started on this before I remembered to turn on the recording. So the GCF, I always look for it regardless of how many terms. There isn't one. So since there are four terms, I'm going to factor by grouping. The greatest common factor here is 4x to the second, and I'm left with 5x minus 3. I have to pull out the negative sign here, and the greatest common factor is 9, and I'm left with 5x minus 3. Okay, so that gives us a common binomial factor of 5x minus 3, and I'm left with 4x squared minus 9. Now I notice that this is a difference of squares. This is 2x to the second minus 3 to the second. So this factors into 2x plus 3 times 2x minus 3. And then, of course, I include my 5x minus 3 with my answer. There is my completely factored form. Okay, on the next one, my GCF, and I do have one, and it is w to the third. So I'm going to factor out my w to the third, and I'm left with w to the second minus 10w plus 25. So I can factor this. I can now am looking for two numbers since my leading coefficient is 1, two numbers whose product is 25 and whose sum is negative 10. Of course, they're negative 5 and negative 5. And since these are the same, that also tells me it's a perfect square. But this factors into w minus 5 times w minus 5. I include my w to the third. Or I can write it as w to the third times w minus 5 to the second. Either way is fine. Okay, my next one here, these are all even, so I know I have a GCF of 2. They don't have any y's. So this is 2 times y squared plus 2y minus 24. So I'm looking, since my leading coefficient is 1, I'm looking for two numbers whose product is negative 24 and whose sum is 2, and they are 6 and negative 4, 6 and negative 4. So this factors into y plus 6 times y minus 4, and then the 2 comes with it. Okay, 5x squared minus 23x minus 10 GCF. There isn't one, so I'm going to have to do a split and group. So, and if you're doing this guess and check, it works just the same. So I'm looking for two numbers whose product is negative 50 and whose sum is negative 23. So I'm going to find all my factor pairs of 50 and find out which of them add up to negative 23. And they are negative 25 and 2. So this becomes 5x to the second minus 25x plus 2x minus 10. Now I can group these. So my GCF is 5x times x minus 5 plus 2 times x minus 5. I have a common binomial factor of x minus 5, and I'm left with 5x plus 2. And there's my answer. Okay, GCF, None. Notice I write it down every time just to remind myself a GCF, and there isn't one. So I'm immediately going to have to split and group. So I'm looking for two numbers whose product is 6 and whose sum is 5. And let's see, they are 2 and 3. So this becomes 2x squared plus 2x plus 3x plus 3. Now I can group. So this gives me 2x times x plus 1 plus 3 times x plus 1, which gives me x plus 1 times 2x plus 3. Okay, 6x squared minus 19x plus 15, GCF. There isn't one. So again, I'm going to have to split and group. Or again, if you're doing it a different method, that's fine. So I'm looking for two numbers whose product is 6 times 15, which I don't know what that is. I think it's 90. Yeah, equals 90, and whose sum equals negative 19. Well, since the product is positive and the sum is negative, they both have to be negative. And it turns out that they are negative 10 and negative 9. So this becomes 6x squared minus 10x minus 9x plus 15. So when I group these now, this becomes 2x times 3x minus 5. I want to remember to factor out a negative, and it's a negative 3. And I'm left with 3x minus 5. So my final answer is 3x minus 5 times 2x minus 3. Neither of those can be factored, so I know I'm done at that point. Okay, so let's see what I've got here. I have each of these multiplied by x minus 2, so I actually have a GCF, and I'm not going to have enough room here. So a GCF of x minus 2. So if I factor out an x minus 2, then I'm left with 3x squared plus 5x minus 2. So this is what I have to now split and group. So I'm looking for two numbers whose product is negative 6 and whose sum is 5, and it's negative 1 and 6. So this becomes 3x squared minus x plus 6x minus 2. Now I can group. So that gives me x times 3x minus 1 plus 2 times 3x minus 1. So I have 3x minus 1 times x plus 2. Bring down my x plus 2, and there's my final answer. Okay, I hope I have enough room here to do this next one. All right, solve this for r. Okay, well, let's see what I'm going to have to do to solve this for r. I have r in two different places. So I think I'm going to have to distribute. So this gives me RL is equal to HR plus HK. Well, I want to get the R's on one side, so I'm going to move this over here by subtracting, so that gives me RL minus HR is equal to HK. I factor out the R, and I have L minus H equals HK. And then I divide both sides by L minus H. And that gives me that R is equal to HK divided by L minus H. And I'm done. Okay, simplifying radicals. Remember, we want to look for groups of 3. So we want to look for perfect cubes if it's 3, if it's perfect squares if it's 2. So if you know your perfect squares, great. If you don't, just break it down into its prime factorization. Okay, so 75 is divisible by 3, which gives us 25. Now, if you recognize 25 as a perfect square, that's fine. Or you can continue to break it down into 5 times 5. So this becomes the square root of 3 times 5 squared. Well, the square root of 5 squared is just 5, and I'm left with the square root of 3. And there's my answer. Okay, 16. Now I'm looking for groups of 3 since my index is 3, is divisible by 2, divisible by 2, divisible by 2, and I get 2. So I have a group of 3. So this is the same thing as the cube root of 2 to the third times 2. So the cube root of 2 to the third is 2, and I'm left with the cube root of 2. Okay, the square. Now I'm looking for the fourth root, so I'm looking for something times itself 4 times. I don't know those off the top of my head, so again, 64 is divisible by 2, divisible by 2, divisible by 2, divisible by 2, divisible by 2. So I have a group of 4. So this becomes the opposite of the fourth root of 2 to the fourth times 2 to the second. So this is negative 2 times the fourth root of 2 to the second, which is 4. Okay, if I have the square root of 36b to the fourth, again, if you recognize 36 as a perfect square, so I can write this as the square root of 6 to the second times b to the second times b to the second. I'm looking for groups of 2. So this comes out as 6, this comes out as b, this comes out as b, which is just 6b to the second. Okay, since we did these broken down, I'll do these where we assume that you know your cubes and the powers. Okay, so I know that this can be written as 2 times the square root of 9 times 3 minus 5 times the square root of 100 times 3. 9 and 100 are perfect squares. So this comes out as 3. This comes out as 10. So 3 times 2 times root 3 minus 10 times 5 times root 3. So that gives me 6 root 3 minus 50 root 3, which is negative 44 root 3. Okay, here I'm looking for groups of 3. So there is a perfect cube in 24. So this is the cube root of 8 times 3 times x to the third, that's a perfect cube, times y to the third times y to the second. So this comes out as 2, this comes out as x, this comes out as y, and I'm left with then the cube root of y to the second. Okay, now there's a couple ways that you can think about this if you have a cube root, an odd root of a negative number. You know immediately you're going to pull out a negative 1. So this is negative 1 times the cube root, and that makes this 16 positive, so this is 8 times 2 times x to the third times x times 11, so I'm going to have x to the third, oh, excuse me, that's a y to the third, y to the third, y to the third, and y to the second. So I have a negative 1, the cube root of 8 is 2, the cube root of 8 is x to the third is x. I've got 1, 2, 3 y's that come out. And left inside the radical, I have the cube root of 2y to the second, which just becomes negative 2 xy to the third times the cube root of 2y to the second. If I want to multiply and simplify, all right, here I'm just going to distribute. I'm going to use FOIL. So this gives me 12 minus 6 root 3 minus 2 root 3 minus the square root of 3 squared. So that gives me 12 minus 8 root 3 minus 3. Oops, I'm sorry, that's plus 6. So this is a 4. Yeah, sorry about that. So that gives me 9, and that's plus 4 root 3. Okay, if I'm just multiplying two radical terms, I can put them under the same radical. Nothing can be simplified here, but let's see what happens if I put them under the same radical. This becomes 18xy. Well, I know that 18 is 9 times 2 times x times y. I know the square root of 9 is 3. There are no more perfect squares there, so I have 2xy remaining under the radical. Okay, so let's see what we can do here. Oh, I don't want to multiply that, so I'm looking for cube roots. So let's see what I can do here. So this becomes the cube root of, 27 times 2. And I'm going to put it all under one radical, times 27. X to the 5th times x to the 15th is x to the 20th. y to the second times y to the 10th is y to the 12th. I know the cube root of 27 is 3. I know the cube root of 27 is 3. Now, if I'm looking for groups of 20, and we talked about this in class, I'm going to divide it by 3. So 20 divided by 3 gives me 6 with a remainder of 2. So that means I can write this as x to the 6th. No. So I can write this, let me do it. X to the 3rd times 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 x to the 3rd. So 1, 2, 3, 4, 5, 6 of those. So that can come out as x to the 6th. And my y to the 12th divided by 3, that gives me y to the 3rd 4 times. And that can come out as y to the 4th. And then inside the radical, and I'm sorry, I did not leave myself enough room here. I still have the 2. I have my leftover x to the 2nd, and that's really all I have in here. So my final answer becomes 9 x to the 6th, y to the 4th, times the cube root of 2x to the 2nd. And we'll stop here.